So, yeah. So, any of this sector, when you want to offer a solution or when you talk of development, all that solution what you offer has to be sustainable. That is what you have to keep it in mind. Next. Next. Slideshow. So you just see, I gave this topic to my research scholars and I asked them around this sustainable development all around the world, what are all those activities that are happening? Can you list that and give me? So you can just see that various countries are focusing on various domains and coming up with a lot of infrastructural projects. If that is world around, in earlier slide. So you just see that all these developments in education sector, infrastructure, and driving innovation and technology, any domain you speak of, there are a lot of activity that are happening, and there is opportunity for any of us to take part in this. So what I did is, when you talk of all of that, I just took two challenges that is key for us. One is water, the another one is energy. And when you talk of water, I'm just trying to give the comparison. If you see the diagram on the right, the size of the earth, and in that small droplet of water what you see, that is the amount of water that is available. And so if you look at size, the diameter of earth is about 12,000 and the diameter of sphere of water, if you accumulate everything and create sphere, that is about 1,385 kilometer. Now more important is, of this small sphere, 97% is salt water and 3% only is the potable or drinking water. Of that, about 12,900 kilometer cube is water vapor. So if I want to use that, I need to come up with technology to take that water vapor. And about one more number you can see, fresh water is stored in the earth, and that is what we are taking out through bore wells and trying to go as deep as possible so that we can take out that water. There are water available in glaciers and ice caps, and today with global warming, we are seeing that those ices are getting melted, and instead of they being available for us to use, they're getting into sea and becoming non-usable water. And one major domain where we use water, potable water, is irrigation. You can just see that India tops the list with about 92% consumption of drinking water for irrigation. And important is somehow when they gave the plot, maybe intentionally, the US is missing. US is missing in the list. And so globally, if you look at 92% of fresh water is consumed for farming. And 3 countries of this consumption, 38% is consumed by India, China, and US. And even though US has less population, you just see that they are consuming as much as or more than what we consume. Now, should we be worrying about this, or others can solve this problem? We really have to worry because we are in danger zone. If you look at other countries, all they are not as red as India. So we really have scarcity of potable water, whereas we have large population to take care. That means that if we have to address the problem of water, it is we have to address, because if you look at the diagram, it is more critical. Just see that normally what do we do? If we forcibly attempt ourselves to consume less water, how much we can save, that number is there. Whether this is okay for us, whether this saving is enough for us, for Indians, that is the question we need to ask. If it is not, if farming is one domain where we are using the water, whether we can come up with alternate solutions for bringing down the consumption of drinking water. If you look at, again, if farming was one domain which was using water, industrial use is another domain which uses the drinking water. Especially the boilers, to cool them, you need water to cool, and that again consumes a lot of water. And sometimes what you do is, you just see that these 2 sectors are the major consumption of drinking water. More importantly, what you do is, after consuming, you're leaving this water to the water body like rivers. So with that water you're doing, one, you have limited resource that is available, and another thing what you're doing is you're harming that resource. And now, once if you damage that resource, to make it usable, you will have to spend money again. So that is again an expensive proposition. So all these are challenges we Indians have to address. And again, if you say challenge, they're all opportunities, because we have to create new jobs, new opportunities for the young minds they're coming out. One solution people are looking at is, the thing should become sustainable. So if you just look at seawater is used as water for fish, and whatever waste fish generates, you use for plants, especially the mangroves and all, and that can become feed for animals, and also these plants can protect soil corrosion, all of that. And if there are a lot of plants, then the temperature level at that area can come down. With that, clouds can get formed, you can get more rains. So these are the concepts some people are working at. People are also looking at some concept called as hydroponics, where water-based farming, all of that, where you use as much as water you want instead of wasting it and putting it into the soil. People are also looking at, in industrial application, if you're using it for cooling the boilers and all, can we use seawater for cooling? People are looking at that. What do is you circulate your hot water, and around that chamber you circulate seawater, and that can cool this chamber. Your sweet water, which is actually circulating inside the turbines, and that is indirectly getting cooled through the seawater. All of that approaches people are doing. But when you're doing that, you will have to worry about scaling. The salt can get accumulated at the inner surface. With that, it can corrode the surface, all of that. Even if there are some biological waste, that can also get accumulated inside the turbine. Again, when I say, if these are the problems, these are again opportunities for someone to solve. One more thing is, okay, if you're using water for farming, and if sweet water is scarcity, whereas seawater is not at scarce, can I use seawater for farming? If I have to do, if I'm using it for, say, paddy farming, I have to make paddy plants or seeds resistant for salt. And for that, you will have to genetically modify the plant seeds so that it can survive in saline water. And Japanese are doing that. Using particle accelerator, you alter the genes of this paddy seed so that it can become the saline water resistant. With that, you can use salt water for farming. So these are all thought processes that are trying to address such problem statements. Now I will come to energy domain, where as electronics engineers, we all were driven by Feynman. In 1959, he was invited to inspire physicists, chemists, biologists at Caltech, give us a path-breaking lecture. He gave a talk saying there is plenty of room at the bottom. And what challenge he threw, many challenges he threw, I have just listed one of that. He asked the audience, all that information that is available in Britannica, can we write it at the tip of the pin? And if you have to imagine what is that thought experiment he was recommending, just written there, the tip of the pin, if you have to write all that data which is available in Britannica, the font size has to be 25,000 smaller than the font size that was used in the Britannica. And he demonstrates through a thought experiment saying that it is possible to do. And today, VLSI technology, what you talk of, the outcome of that is all those ICs that are available inside this, in your TV or mobile, is the outcome of such a thought experiment. Today, if you talk of pen drive, you can just imagine what was the size of the data it could handle a few years back and what is the size of the data it can handle today. That is what you're talking of, writing data somewhere, no? And people really got inspired by Feynman's lecture, and they demonstrated that what thought experiment he talked in 1959 is actually realizable. If this was one inspiration people derived, the other inspiration people derived is someone called as Moore. He proposed Moore's law. What he said is, if the number of transistors that are available in the integrated circuit is 100 today, after 2 years, it will become 200. After another 2 years, it will become 400, like that. The area remains the same. The number of devices that will get into that area will double. And people got challenged, or in the sense that they took it as challenge. Every year, the research was to make sure that we follow the Moore's law. And what was that material people were using? It was silicon. And silicon said that you want to double, I have space. And up to 2020 or 2015, we could follow Moore's law. Now silicon is saying that I'm giving up. I cannot give you any more space. So it is throwing challenges at us, and it is also giving us more opportunities for us. So 1971, when Intel released its processor chip 4004, there were 2,300 transistors in it. And today, we talk of 500 nanometer technology in same area processor. There are 50 billion transistors present there. And that is the power of VLSI technology. That is the power of people working in this area and contributing to these numbers. So, what is that building block inside a modern IC? You need not have to worry what is that NAND gate, NOT gate and all. The story behind that, if you get the message behind that, if you get, that is enough. So, if you break open a IC and start seeing inside, everywhere you will see something called as a NAND gate. And that NAND gate is made up of, again, NOT gates. So everywhere you will find NOT gates or inverters. So this is just a diagram of an inverter. What does that do? If you feed a 1 at the input, it gives you a 0. If you feed a 0, it gives you a 1. So when we talk of digital IC, it is world of zeros and ones. Whatever I speak, if it gets converted from speech to text, whatever document you type in your mobile or computer, even though these are textual content, but when it goes to the processor, it goes at ones and zeros. So this is a device, or when you talk of inverter, it just inverts whatever input you give at the input. And again, don't worry about when you do this, when you transfer 1 to 0 and 0 to 1, with all this, all that processing, what you're doing with your mobile, finally it breaks down to this. Okay, so one resistor you see in that circuit, which is written as R. Whatever energy you draw from the battery to do your work, part of the energy gets consumed in that resistor. So that means that if, say, 50% of the energy gets consumed in that resistor, it is something like I spent 100 rupees, I wasted 50 rupees, in return I got only 50 rupees. That is not an efficient way of solving a problem. My return is only 50%. So this message, if you get, that is enough in this circuit. So how much is the wastage of power in such a scenario? Or what is the challenge when I do this 1 to 0 and 0 to 1 transition? So, two scenarios, there is a current flowing. You see that either 1 to 0 or 0 to 1, there is a current flowing through that resistor, and that is wasting energy. So somehow, if it is not helping me, I have to get rid of. That is the challenge with us. How much energy is getting wasted in that resistor? If you talk of modern day chip, which operates at high frequency like 1 gigahertz or so on, you are consuming about 125.25 kilowatt. Of that, 125 kilowatt is wasted in the resistor, and rest of the energy is in the capacitor, that is stored energy. So first number is a waste. And stage. I will give you a picture of what would happen. Again, forget about these numbers. Suppose I want to draw whatever current I mentioned from Samsung battery that is there in my mobile. If I want to draw a current of 25050, that is what my earlier slide showed. If I want to draw that current from one battery can give me only 3300 milliampere hour. Surely in battery that numbers are written. But that current is not enough what I get from one battery. I want to get 25050. That means that I need 7591 such batteries which are shown there. Each battery weighs about 50 grams. That means that for the modern processor, my battery weight itself is 380 kgs. Can you imagine this device becoming handheld device with such a weight of battery inside this? So that means that not only it is wastage of power, it is making my device bulky. So this cannot be the solution for us. So people worked on this. So if that 125 kilowatt is waste, it is adding weight, how can I eliminate that? So people looked at alternate solutions. So if that resistor is a problem, can you eliminate that resistor? So people looked at putting a complementary device. If the bottom one is on, top one is off. If the top one is on, bottom one is off. That is what people looked at. And as soon as you did that, for the current flow, that resistor got eliminated. Once that resistor got eliminated, your resistor wastage got eliminated. You are left out with only 250 watt to handle. And for 250 watt, with a 5 volt battery, now the current you want to draw is only 50 amps. And if you want 50 amps, you just need 15 batteries, and that will be about 0.75 kg. This is a manageable number, but still you need 15 batteries. You don't see 15 batteries inside this, no? You will see only one battery. So that means that this again is not the complete solution. People have worked much more on the circuitry so that the wastage is reduced, weight is brought down, and all of that. One more example I'll give you. Today, people are talking of EVs. Your two-wheeler has become electric vehicle, four-wheeler is becoming electric vehicle. So circuit, what you see on this slide is called as a H bridge. There are 4 transistors. In the middle, there is a motor. If the motor has to rotate in one direction, you have to switch on 2 transistors connecting the power supply to the motor. If the motor has to rotate in reverse direction, you have to switch on the other 2 devices. The motor will rotate in reverse direction. If you have a 3-phase motor, then you need 6 such devices, and how the circuit functions, you need not have to worry. But you need a semiconductor device. In one case, 4 of that. In another case, 6 of that, if your motor is a 3-phase motor. So again, if your EV has a battery of 40 kWh, kilowatt hour, you can power a 40 kilowatt electric motor for 1 hour if you want. That is, if this motor has to run for 1 hour, that means that your rating is 40 kilowatt hour. If battery voltage is 280 volts, if the motor rating is 40 kilowatt, you're talking of drawing 143 amps of current. And when you draw this, okay, motor needs that current, but that current has to pass through 2 of your devices. That means that device should be able to carry that current, and at the same time, it should not consume any of that, because that is not helping you, or it is just providing a path. But if it consumes power, then it is again wastage of power. So what devices people have come up with? In olden days, when we were studying, we used to study something called as thyristor or semiconductor rectifier. After that, power BJTs came, MOSFETs came, IGBT came. Again, what are these devices? You need not have to worry. Today, if you go to college and refer to power electronics book, you don't see mention of thyristor at all. Why did it happen? One, it was slow in operating, and once it is turned on, you couldn't turn off it easily. So if it is slow in operating, today's domain where everything has to be faster, you can't do that using thyristor or SCR. So this is ruled out for today's application. When you talk of transistor, for it to conduct, you have to supply current to the base terminal, which is marked there. And that current is of the order of 2.5 amps. How are you deriving the drive signal? Today, you want to drive everything using your computer. If you ask your USB port to give you 2.5 amps of current, USB port will say that I can't give you. So that means that if I use BJT, then I cannot handle this device using computer or laptop. So that means that for modern application where everything you want to control using computer, you cannot use BJT. So again, using BJT in modern applications is ruled out. When you talk of MOSFET, it is enough if you apply 4 volts at the gate terminal. And I easily get 5 volts battery. And if my laptop operates with 5 volts power supply, I easily get 4 volts. If I'm able to apply 4 volts at the gate terminal, I can turn on the device. So that means that I can easily write a computer program, generate this voltage, and control the device. So that is why MOSFET today has become very, very popular. And so both MOSFET and IGBT are equally good for modern applications. And in today's world, people use only these 2 devices to control electric vehicle. So if I have 2 devices, I have to now select between the 2, which is better. So I have a table here. Again, these numbers you need not have to worry. I'll just show you this. If you look at voltage rating and current rating, thyristors are the best. So that is why I have put green. So that means that if you look at only this rating, thyristor will say that I can do that best I can do, rest all will be nothing in front of me. But problem with that is, it is low in responding, and once if it is turned on, it cannot turn off easily, it is difficult. So that is not good for thyristor. When you talk of BJT, its rating is also as good as thyristor, not means equally good, not best when compared to thyristor. Bad thing about that is, one, controlling on and off of the transistor is difficult, and again operates at low frequency. When you talk of MOSFET, its rating is less, but it can operate at high frequency and very simple device to control. So that means that the green what I see in transistor and the green what I see in MOSFET, if I can get the benefit of both, that is the best device I can use. So if you look at IGBT, everything is green. So that way, when you have to decide between MOSFET and IGBT, IGBT is the best device you can use. And how best it is? Our Professor Indian-born Jayant Baliga went to US. He developed IGBT, and he got this year Millennium Technology Prize for inventing IGBT. And what is the contribution this device has done? It has reduced CO2 emission by 180 trillion pounds over the past 30 years. That is the power of one invention, and that is what is sustainable development, no? So let us be proud of Baliga, what did he do to this world. And whether this is all is the solution. So the device MOSFET, what I talked of, has a structure something like this. Don't worry about what is this doing, all of that. So when you connect this device to control the motor, how the current is flowing? The current flows from drain terminal to the source terminal. This is the one which carries the motor current. But there is also a diode junction formed between source and the body or bulk of the device. And this current will also flow, which is called as leakage current, or this is the current, if it flows, that results in loss. And you don't want this current. So people are looking at how do I eliminate this current. So what you have to do is you have to reverse bias this junction. Again, what is reverse bias and all, you need not have to worry. If you reverse bias, you can reduce this current. With that, where the terminal has to be connected, it is written there. A passenger EV has a battery voltage of about 800 volts. If it uses IGBT operating at 10 to 15 kilohertz, it has a switching loss of about 2 to 5%. So that is the loss. In the sense that if you are spending 100 rupees, 5 rupees you are wasting. So I'll just try to convert it to number where you can understand it easily. So with a 3% loss, if you say 100 kilowatt motor, if you are using, you are losing about 3 kilowatt. If your global EV count is about 40 million, that means that you are losing 120 gigawatt. If all these vehicles are running for 1 hour a day, every day you are losing 120 gigawatt hour of energy, and 1 kilowatt hour is 1 unit. If 1 unit is costing you 6 rupees, that means that per hour all over world with 40 million EVs, you're losing 72 crores. I'm just giving you the numbers. Just see what is the level of loss just with 3% loss. So how do I eliminate this? You have to avoid PN junction loss. And why that loss is coming? Because there is a leakage current. Why there is a leakage? The electrons that are flowing are finding a barrier height which can easily jump that and come to the other side. If this loss has to reduce, current has to reduce. If that has to happen, the barrier height has to increase. And so silicon is saying that my barrier height is something like 1.1 electron volts. You just see that, assume that it is 1.1 meters. So that is not enough, because that is resulting in huge loss. So now people are looking at alternate materials like silicon carbide, gallium nitride, where their barrier height is at least 3 times more than silicon. So with that, leakage current will come down and you will have less loss. So people are also looking at various technology solutions. You want to avoid PN junction. So what you do is, in between your bulk and your device structure, you create an oxide, and that is called a silicon on insulator technology. And so you don't have a direct PN junction. There is an insulator that prevents current flowing. With that, you eliminate leakage. Now you have to worry about how do I create such a scenario. So you use 2 silicon wafers, bond them with in-between oxide, and one of that you polish it so that it looks like the last diagram what you see. Now what is the problem with this solution? Problem is you invested on 2 wafer. That means that if your profit was 100 rupees before, now it is almost like 50% or less than that. So you have cost parameter coming into the solution. There are various other solutions. Probably this will be too heavy for you. So I'll just leave how people are having a problem and coming up with various solutions. People are also looking at alternate structures for the control of the current flow. So these are double gate, FinFET, spintronics devices are all the new additions to the research that are happening. So this is just my thought as an electronics engineer. Took two examples of problem statement, how we are making sure that our solutions are becoming better solutions. And so with materials engineers, electronics engineers, what we have to look at is every problem as an opportunity and come up with novel solutions. Let sustainability be the mantra in coming up with the solution of a problem. Before I conclude, there is a problem statement here. So I don't know if you have come across this. I had taken the example of Rajdhani train. You can even take of Vande Bharat Express. Today, Rajdhani or Vande Bharat are the high-speed trains. And when it is high-speed train, as a consumer, everyone wants to use that. That means that every station would like Vande Bharat or Rajdhani to stop. If that happens, then its speed will go. So that means that if the speed goes, then people will not use it. So I should not lose the speed. At the same time, I have to make sure that passengers from every station is picked up. So this is the problem statement. Just see how Chinese are trying to solve this problem. Hello. Hello. Can you play the video? Video, wo link click kijiye. So just look at this Chinese solution. If it is not playing, you go to the folder, open that file. So probably it is giving you some time to think of a solution. Tell me. You need a mic.
जैसे राजधानी ट्रेन आ रही है सर, ठीक है सर। ओके, राजधानी ट्रेन रनिंग में है, ठीक है। और मैं जैसे हुबली स्टेशन पे हूँ, तो हुबली से ही एक बोगी रनिंग रहेगी, उसके साथ सेम स्पीड से रनिंग हो जाएगी, तब सेम स्पीड से कनेक्ट हो जाएगी। वो ट्रेन भी जैसे 120 की स्पीड है और हुबली की बोगी की स्पीड ही 120 है, तो दोनों को एक साथ कनेक्ट करके वो बोगी चिपक के साथ ही चली जाएगी। दे बोथ आर सेम स्पीड।
提前进入车顶的周转车厢。旅客们，北京开往广州方向的168次高速不停站火车马上就要通过本站，请前往广州方向各站的旅客提前进入站台的周转车厢。
下次再见。
旅客们，武昌车站到了，请大家按先后次序下车，下次旅行再见。
So you can just see the solution. So he was also trying to give you a solution which is closer to what is there here. So he worried about only picking up the passengers. He didn't worry about dropping the passengers who are in the train. So this solution is, you just see the novelty of the solution. If you have seen the railway station, whenever the train comes, people who are inside the train are worried about getting down before the train starts, and people who are on the platform are worried about getting in. In the process, you can just see the rush that happens at the door. In this solution, if you just see, for the people who have to get into the train, there is already a bogie in the station. And when the train is coming, it is just picking up this bogie, and passengers who have to get down, they are all in one bogie. The train is just leaving that bogie and going. So there is no rush for people to get in. There is no rush for people to go out. So this is the beauty of a solution, and we need to come up with such solutions. You can just see that it is addressing all that problems you can come across when you will have to, when you look at civil solutions. You are trying to make sure that every customer is taken care. So thanks to internet and Google for all that material I've used is from the internet. Thank you.
Thank you, sir. Sir, I request you to please stay back for a minute.
Yeah, thank you.
Now I request Shri D.P. Kumar sir to please come on stage and present memento to Dr. Soma Shekhar Bhatt sir. Sir. Thank you, sir. As we know, our country had a great loss by the demise of Sri Ratan Tata sir. Sri Ratan Tata sir's vision and commitment had transformed industries and inspired countless individuals. Through his dedication to innovation, social responsibility, and excellence, he has not only shaped the business landscape but has also uplifted communities across the globe. Sir Tata's legacy is built on integrity, perseverance, and a deep sense of purpose. He has shown us that true leadership is about serving others and making a lasting impact. Let us all stand together and give him a standing ovation and 1 minute of silence, please. Thank you, everyone. You may please sit down. Now, it's time to bring to the stage our talented dancers who will transport us to the vibrant world of Kamsare. This traditional dance, with its energetic rhythms and captivating movements, celebrates the rich cultural heritage of our region.
ಬಾರೆ ಗೆಳೆಮೈನ ನೋಡು ಬಾರೆ ಕಂದನ ನಲಿದು ನೋಡು ಬಾರೆ ಕುಣಿದು ನೋಡು ಬಾರೆ
ಏಳು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ಕುಂತ ನಮ್ಮ ಮಾದೇವ ನಾಗು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ನಿದ್ದೆ ಮಾಡು ಮಾದೇವ ಈ ನಿದ್ದೆ ಸಾಕು ನೀ ಎದ್ದು ಬಾರು ಬಿಡಿ ಬಿಡಿ ಎಲ್ಲ ದಾರಿ ಬಿಡಿ ಬರಿ ಮಾತಿ ಎಲ್ಲ ಜಕ್ಕಲ್ಲ ಹಂಗೆ ಕುಣೀರು ಹಿಂಗೆ ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಎದ್ದು ಕುಣೀರು ಬಿದ್ದು ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಏಳು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ಕುಂತ ನಮ್ಮ ಮಾದೇವ ನಾಗು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ನಿದ್ದೆ ಮಾಡು ಮಾದೇವ ಈ ನಿದ್ದೆ ಸಾಕು ನೀ ಎದ್ದು ಬಾರು ಬಿಡಿ ಬಿಡಿ ಎಲ್ಲ ದಾರಿ ಬಿಡಿ ಬರಿ ಮಾತಿ ಎಲ್ಲ ಜಕ್ಕಲ್ಲ ಹಂಗೆ ಕುಣೀರು ಹಿಂಗೆ ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಎದ್ದು ಕುಣೀರು ಬಿದ್ದು ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಕಾಡೆಲ್ಲ ತುಂಬೈತೆ ಹೂಗಂಧ ಕಾವೇರಿ ಹರಿದೈತೆ ಏನ್ ಚಂದ ಕುನಿಗ್ಯಾವೋ ಗುಬ್ಬಿ ತಂದ್ಯಾವೋ ಗುಟ್ಟು ನಲಿದ್ಯಾವೋ ನವಿಲು ನುಲಿದ್ಯಾವೋ ನಾಗ ಕೊಡುವಾಗ್ಲೆಲ್ಲ ಕೊಡ್ತಾನು ನಮ್ಮಪ್ಪ ಶಿವ ಅವನು ಒಲಿದರೆ ಕೊರಡು ಕೊನರೆ ಬಂಗಾರ ಬಾಳಪ್ಪ ಅಕ್ಕರೆ ಮಾತಾಡಿ ಪೂಜೆ ಮಾಡಿ ಅಂದವನೇ ಮಾದೇವ ಏಳು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ಕುಂತ ನಮ್ಮ ಮಾದೇವ ನಾಗು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ನಿದ್ದೆ ಮಾಡು ಮಾದೇವ ಈ ನಿದ್ದೆ ಸಾಕು ನೀ ಎದ್ದು ಬಾರು ಬಿಡಿ ಬಿಡಿ ಎಲ್ಲ ದಾರಿ ಬಿಡಿ ಬರಿ ಮಾದಿ ಎಲ್ಲ ಜಕ್ಕಲ್ಲ ಹಂಗೆ ಕುಣೀರು ಹಿಂಗೆ ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಎದ್ದು ಕುಣೀರು ಬಿದ್ದು ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ತಂಪಾದು ಸೊಂಪಾದು ಬಾನೆಲ್ಲ ತಂಪಾದು ತಂಪಾದು ಮಾಡೆಲ್ಲ ಈ ಹಕ್ಕಿ ಹಾಡ ಆ ತುಂಬಿನಾದ ಚನ್ನ ಚಕೋರ ಚೆಲ್ಲಟಗಾರ ಚನ್ನ ಮೈಗಾರ ಮಾದೇವ ಕೇಳಯ್ಯ ದುಂಡು ಎದ್ದೇಳೋ ಮಂಡೆ ಕೊಡುವಾಗ್ಲೆಲ್ಲ ಕೊಡ್ತಾನು ನಮ್ಮಪ್ಪ ಶಿವ ಅವನು ಒಲಿದರೆ ಕೊರಡು ಕೊನರಿ ಬಂಗಾರ ಬಾಳಪ್ಪ ಅಕ್ಕರೆ ಮಾತಾಡಿ ಪೂಜೆ ಮಾಡಿ ಅಂದವನೇ ಮಾದೇವ ಏಳು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ಕುಂತ ನಮ್ಮ ಮಾದೇವ ನಾಗು ಮಲೆ ಮ್ಯಾಲೆ ನೀ ನಿದ್ದೆ ಮಾಡು ಮಾದೇವ ಈ ನಿದ್ದೆ ಸಾಕು ನೀ ಎದ್ದು ಬಾರು ಬಿಡಿ ಬಿಡಿ ಎಲ್ಲ ದಾರಿ ಬಿಡಿ ಬರಿ ಮಾತಿ ಎಲ್ಲ ಜಕ್ಕಲ್ಲ ಹಂಗೆ ಕುಣೀರು ಹಿಂಗೆ ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಅರೆ ಅರೆ ಎದ್ದು ಕುಣೀರು ಬಿದ್ದು ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಹಂಗೆ ಕುಣೀರು ಹಿಂಗೆ ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು ಎದ್ದು ಕುಣೀರು ಬಿದ್ದು ಕುಣೀರು ನಮ್ಮುತ್ತು ಮಾದಯ್ಯನಿಗೆ ಪಕ್ಕಿ ಕುಣೀರು
The energy, grace, and rhythm you shared today have not only entertained us but also deepened our appreciation for our cultural heritage. Thank you for your hard work and sharing your talents with us. We are really inspired by your artistry. We have now the privilege of hearing from a second speaker who will dive deeper into Sustainable Development Goal 9, Industry, Innovation and Infrastructure. Please join me in welcoming Shri Madhusudan Sir to the stage.
Pointers. Yeah. Podium should be. Hello. Good afternoon, everyone. Before starting this presentation, I have a confession. I'm not a very good speaker like Somsekhar Bhatt sir, so I was not as extempore as him. It was wonderful that his presentation was very wonderful. I'm a mechanical engineer. My presentation and speak will be as straight as possible. Thank you. So, this World Standards Day, one second, hand mic idea. Vijayapur sir, hand mic.
Check. Check.
Thank you. So this World Standards Day celebration is jointly done by ISO, IEC and ITUS explained in the morning. That actually this SDGs is Sustainable Development Goals. Also it's a global goals adopted by UN as long back 2015 as a universal call to action to end poverty, protect the planet and ensure by 2030 all the people should live healthy and in peace and prosperity. The creativity, know-how, technology, and financial resources from all of society is necessary to achieve the SDGs in every context. So, as a JSW, let us see what we are in these goals, which drill down to 169 targets. So, presently we are at 9 industry, innovation, and infrastructure. So that 9th goal, industry, innovation and infrastructure, is basically build resilient infrastructure, promote inclusive and sustainable industrialization, and faster innovation. There are main 7 targets. So there are some constraints and challenges in achieving those 7 targets. These are the constraints: growth stagnation, geopolitical instability. Geopolitical instability, one of the example is what is going on in the Middle East nowadays because of the wars and this one, that growth is hampering what's happening at Russia and Ukraine. They are the reason. That is a typical example for geopolitical instability. And of course, the inflation. So countries like Pakistan, Afghanistan, and other LCD, this one, countries, they're struggling because of the economic slowdown. And the logistic challenges, again, one typical example is, for example, China wants its dominance over South China Sea, and it wants to control the transportation. And the culprit is energy and the CO2 emission, where our industry plays a very important role and major role, that we will come to that later. And of course, the broader global economic slowdown. These are the constraints. There are the challenges in achieving those 7 standards pertaining to 9th goal of sustainable development. Is it not visible? Okay. You see, these are the 17 SDGs. And the ISO standards for sustainable development goals. Okay? Robust and effective standards are crucial for driving and measuring progress towards SDGs. So here you can see this ISO that is given publicly available standards. There are more than 50,000 standards are available to achieving, that gives the guidelines to achieve the SDGs. So this 9th one, that there are around 15,368 standards are available publicly, freely. So this is the towards India's vision pertaining to steel manufacturing, steel policy. So that is called 2047 Amrit Kal. This is coined by Ministry of Steel. So by 2047, where we will be celebrating our 100th year of independence, by that time we should be producing 500 millions of steel from current capacity of 154 million tons of steel, with 20% contribution to the global steel production. Now, China is producing more than 800 million tons of steel, where India, we are in the second position rather. We are producing only 154 million tons of steel. So how we achieve this? By increasing the per capita steel from 70s. So what happens with that? Increasing the export of steel to 20%. So tremendous amount of foreign currency earning. So boosting production of high-grade steel to 50% of total production. Next, that reducing CO2 emission intensity by 50%. Now current rate of 2.6 tons of CO2 per tons of crude steel. We need to reduce it to 1.3 tons of CO2 emission per ton of crude steel. That is a very challenge in front of any steel industry in the world. So raising capacity to produce steel through scrap, we can go to 300 million tons, and raising contribution of steel sector GDP to 2.3% to 3.5%, while providing direct and indirect employment to 85 lakh people. So presently, the GDP contribution of steel is just 2.3%. That can be increased to 3.5 if we achieve 500 million ton. So this is the vision statement of 2047 to make a global champion in production of high quality steel by adopting advanced technologies driven by innovation while traversing a trajectory towards green steel and fostering circular economy and establishing a brand India in global market. So the energy and CO2 emission, if you see that iron and steel sector's contribution is 26%, that is very huge. That means the steel industry is one of the major culprit in green gas emission. So you further drill down, the power consumption and this one, CO2 emission, if you go to sector-wise, if you take iron and steel alone, it is 28%. Direct industrial CO2 emissions, while cement is 27% and others is 26%. Unfortunately, we are in the business of iron, steel, and cement as well. So the responsibility lies, very huge responsibility lies on us to reduce the CO2 emission by various adopting innovation technologies and sustainable goals. Yeah. Only that thing, yeah. Oh, okay, fine. Sorry, I was blocking some of the views over there. It seems. Okay, as a JSW group, we are in the business of steel, and as a in steel sector, we are the leading integrated steel producer. Installed crude capacity of 28 million tons per annum, and growing to 50 million ton by 2030. And we have a market share of capitalization of $17 billion. So we are in the business of JSW Energy, where we're producing electricity, power producer with installed capacity of 4.6 gigawatts. We have both hydro, renewable, and thermal routes, growing to 20 gigawatts by 2030. And we have a JSW infrastructure and engaged in development and operations of ports, and we have paints, and we have cement. And we have an operating capacity of 14 million tons per annum of cement, and in the near future we will be becoming 25 million tons of cement. So these are some of the advanced steel products and applications JSW has recently being in the business of manufacturing and supplying. So we have a hot-rolled products in which construction, infrastructure, general engineering, pipes, tubes, yellow goods, and whatnot. And next we have a coated products, where it is pipes, tubes, roofing, general engineering, solar appliances, and the color-coated sheets are made. And then we have a specifically color-coated products used for sandwich profile by this one, and the roofing. And we have developed tin plates also recently, and that has a huge consumption in oil can, non-oil can, food cans, and etc. Of course, our cold rolling products being used in automotive general engineering. We have been the first integrated steel supplier to supply all the major automotive manufacturers in India, right from Toyota, Honda, Hyundai, Maruti Suzuki, Volkswagen, and all. You name it, all are our customers. And recently we have developed electrical steel coil and sheets, where it goes to auto products and general engineering, transformers, and all. And we have a very high strength alloy steel products. They are exclusively being used in automotive steel sector, because in automotive you require very high strength. Safety is the prime issue, and there we require high strength with low weight. So how we map ourselves towards this SDG, and what initiatives and projects we have taken up and planning to do in future. So, as a company, we aim to address the environmental impact of its operations with a strategic and long-term approach. This involves upgrading and retrofitting infrastructure to make sustainable, with increased resource use efficiency and greater adoption of clean and environmentally sound technologies and industrial processes. To achieve this, JSW is continuously evolving to improve raw material quality, energy efficiency, increase steel making via electric arc furnace, and exploring possibilities in carbon capture and storage utilization. So one of the contributions we are making is installation of BF gas holders. Instead of emitting CO2 directly to the atmosphere, we are capturing it in a gas holder. And top pressure recovery turbine in blast furnace, hot stove waste heat recovery, installation of energy monitoring and management systems, coke oven waste heat recovery boiler, LD converter dry gas cleaning, and gas holder and LD converter waste heat recovery boiler. So, if you talk about green steel, I'm very proud to share that we have been awarded green steel producer in hot rolled and cold roll as well, cold roll products as well. So by 2030, it's estimated that by 20% of our total production should be green steel. Green steel means what? Steel not being green. So steel is produced with lowest amount of emission of CO2 is called green steel. So 20% of our steel we should be producing by green. By 2047, 50% of our total products should be produced in green route. And by 2070, many of us won't be there, all of us rather. 100% of steel will be produced in the green route. So how it is done? 60% steel production through scrap. Instead of reducing iron ore. Reducing iron ore involves a lot of carbon usage, reduction and emission of CO2s and other harmful gases. So 60% of steel is through scrap, coking coal import independence, maximum use of pellet, again that reduction of direct use of iron ore and reduced iron ore, and 100% gas-based direct reduced iron. Instead of using oils, heavy oil and diesel oil, 100% gas-based. Increased use of green H2, increased use of CCUS, 100% renewable energy use. So focus area is low emission of CO2 again, that cradle to grave, life cycle assessment and improvement. That means from very beginning to the end of the life of a product, how the carbon and the CO2 emission is made, that is captured. Able to produce steel with low nitrogen from scrap route, steel for hydrogen pipelines, steel for renewable energy. This will be producing. So presently, what we are thinking of is process transition, BF blast furnace and BOF route through pulverized coal using natural gas. So natural gas plus 2% hydrogen, natural gas plus 10% hydrogen, and using EAF are some of the technologies we are adapting, planning to adapt in coming days to achieve that 50% of green steel production. So if we achieve 50% of green steel production, what happens? Our carbon emission will come down from 2.6 to 1.3 tons of crude steel production. That's very huge in here. So our decarbonization commitments are like this. So 1.95 tons of CO2, that is 20% reduction from 2021. And the strategic levels are ensuring energy efficiency, fueling on energy transition, renewable power, actively improving material quality, alternative fuel sources, increase steel scrap usage, the pilot object to decarbonization of technologies and enhancing process of efficiencies. So this can also be achieved with RRR, concept RRR, that is reduce, recover and recycle. What is to reduce? To reduce the inefficiency and increase the process efficiency, reduce the carbon source, use alternative fuels and use the reductants. So what to recover? Carbon capture. Instead of emitting CO2 to the atmosphere, capture it and use it in a useful way. So electricity generation and process integration. What to recycle? Use the scrap, and again CO2 is reused by breaking it to oxygen and CO. So again, use carbon direct avoidance, that is CDA nowadays. So how it is, there are many technologies in the pipeline. So hybrid is one of the technology where direct hydrogen reduction done through for green hydrogen. And Midrex H2, it's in the pilot plant stage, usage of natural gas, oil gas-fired gas as primary source instead of coal alone for reduction. So H2 future, replacement of coke with hydrogen. This is very huge. So in any steel plant, coke oven and use of coke is the main culprit for the CO2 emission. So there is one more maker under CALCOS, usage of DRI H2 based and EAF route. So this is a recovery also we can use. What is recovery? The integration of process using gas grids for its internal usage. For example, from the blast furnace and the gases what is emitting, that CO2 is treated and pure CO2 go to CO2 storage, and CO is again used in blast furnace and other reheating furnaces. Again, recycling. The carbon capture, storage and usage concept converts CO and CO2 in valuable products, requires additional byproduct manufacturing units. So capital cost is required. Again, iron ore sinter, that blast furnace gas, CO2 source, that is chemically it's treated to make it hydrocarbon products. What are the hydrocarbon products? Chemical fuels, methane, CH3OH, like that. So presently, you can see the first one. What we are using is Corex, Finex, such as his melt and all. Their CO2 emission is very huge, up to 2.2 tons of CO per tons of cast steel produced. So if we comes to Midrex and finally in the hydrogen steel making, so it becomes almost 0.05 to 0.15 tons of CO emission per tons of steel. So what is green steel, green hydrogen? This slide gives you some idea of what is green hydrogen. So there are many types. Brown route, matlab, we use coal gasification, highest greenhouse gas emissions, and the cost is up to $2.1 per kg of H2. If we produce hydrogen through coal route, so there will be a CO2 emission. You cannot call it green. So then we have a gray hydrogen method where natural gas has been split into hydrogen and CO2. In this case also CO2 is emitted into the atmosphere. That's why it is called gray. So natural gas, steam methane reforming, so high green gas emission again. So in blue hydrogen, where India is operating between blue and green nowadays, here also the split natural gas into hydrogen and carbon dioxide, where carbon dioxide is stored and reused. So here as a natural gas, advanced gas farming, here low greenhouse gas emission will be there. But if you come to green hydrogen technology, here the water is split into hydrogen by electrolysis powered by water or wind. So in this, no emission of CO2. So it is completely green. Renewable electricity, electrolysis, and potential of zero greenhouse gas emission is the consequence. So future of iron making, a 90% CO2 reduction. This is what JSW is aiming for. So presently, 1.5 metric ton of CO2 is released to atmosphere against the production of 1 metric ton of crude steel. Even if you say 1.56 million ton of CO2 is emitted to produce 1 million ton of crude steel. So when we achieved green hydrogen method, so there is hardly 0.1 million ton of CO2 per production of 1 million tons of crude steel. So how the BIS and quality control order is helping in this? So for ensuring availability of quality products to customers, QCOs are issued by various ministries, departments of Government of India, applied to steel and steel products specified in quality control order for goods and articles, and compulsory use of standard mark, penalty for contravention, and around presently 149 BIS standards and 7 goods and articles are covered in present QCO. The numbers may be little here and there, right? Yeah, because pertaining to steel, this much less. In standardization activities, BIS formulated standards national action plan for the 5 years plan starting from 22 to 27, both ferrous and non-ferrous industries. BIS is making efforts to introducing the standards in curriculum to extend the awareness. So in a nutshell, BIS in association with ISO developing standards in line with the SDG targets. So focusing on energy efficiency and CO2 emission reduction, implementation of innovative technologies, monitoring SDG targets at industry level, encouraging development of innovative technologies by providing infrastructure and aid through BIS committees. Thank you.
Thank you, sir, for your insightful presentation on sustainable development goals. We really appreciate your valuable contribution and the inspiration you have provided to us. Now I request Shri DP Kumar sir to please come on stage and present memento to Shri Madhusudan sir. Thank you, sir. Now we come to a very special moment in our program, the felicitation of our esteemed licensees and dedicated mentors. These individuals have not only achieved remarkable milestones, but have also paved the way for others to follow. Their hard work, commitment, and guidance have made a significant impact on our community. As we honor them today, let us acknowledge the invaluable contributions and the inspiration they provide to the Bureau. I request Shri DP Kumar sir to please come on stage, Shri Pradeep Kumar sir to please come on stage. We are very happy to announce I also request Mrs. Mercy Rani ma'am and Mr. Ashutosh sir to please come on stage. We are very happy to announce that this year we have 3 All India First licensees. I would like to announce their names and I would request the person who are representing those to please come on stage and take the honors. IFB Industries Limited, Goa. Yes. Limited. Okay. Messrs. JSW Steel Ballari. I want the audience to please clap for them. Thank you, sir. Thank you, sir. Messrs. A1 Steel and Alloys Private Limited, Ballari. I would like to call Sapan from Messrs. A1 Steel and Alloys Private Limited, Ballari. Thank you, sir. By creating standard clubs in various institutions, Hubli branch office is successful in creating awareness about BIS standards, purchasing quality, checking authenticity of products, and understanding our rights as consumers. This program is being done to start the promotion of standards by educating the children first, as they are the nation builders. Today, we are felicitating the mentors who are backbone of the Standard Club members and who bridge gap between the bureau and the institution. I would request the mentor, Mr. Avinash Kotian from Government PU College, Kalgadgi, to please come on stage and receive the honor. I would now request Mr. Rajesh Ainur from Government PU College, Sagar, to please come and receive the honor. Mr. Rajesh Ainur. Thank you, sir. Now I would like to call Mrs. Ashwini Patil ma'am from KLE's International School, Belgavi. Now I would like to call Mr. Shashank sir from Jain College of Engineering, Belgavi. Mr. Ajay KS from Government Industry Industrial Training Institute, Bhadravati. For BIS Standard Club members, having relevancy to academia, we arrange exposure visits for students to the industries who are our licensees. Today, we'll also like to felicitate those industries who supported us for being part in the exposure visits. I would like to call someone from Messrs. Jai Hind Tubes. Jai Hind Tubes. Messrs. Sanjeevani Pipes. Messrs. Oshima System Private Limited. Messrs. AK Kittur Veneers Private Limited. Messrs. Mohit Ispat Limited. Messrs. Aquakeen Goa Water. Messrs. Gokul Industries. Messrs. Tanvi Irrigations. Messrs. Thirumal Enterprises. Tanvi Irrigations. Yes. Sir is from Tanvi Irrigations. Thirumal Enterprises. Messrs. Yashutsav Enterprises. Messrs. Spurti Packaging. Messrs. Phenolex Cables. Yes, sir. From Phenolex Cables. संयुक्त संघ. Amit Capacitors Limited. Prakash Metal Products. Prakash Metal Products. Limited. Grasim Industries Limited. Grasim. Accessories Private Limited, Vega Auto Accessories Private Limited, Sayadri Polymers, Vigneshwar Polymers, Vigneshwar Polymers. Thank you, sir. Thank you, ma'am. I would now request Sri Ashutosh Agarwal to express his gratitude to all the invitees and the participants by proposing a vote of thanks.
Good afternoon, everyone. I stand here today to express my heartfelt gratitude to each and every one of you who has contributed towards the success of our event Manak Mahotsav. On the occasion of World Standard Day, without your support, this event would not have been possible. Shri Jagdish Shettar, former Chief Minister of Karnataka and Member of Parliament, Belgavi Lok Sabha, and guest of honor Professor S.R. Mahadev Prasanna, Director of IIT Dharwad, as they have taken out time for this event from their busy schedule. And respected Shri D.P. Kumar Sir, Head BIS, and Mrs. Mercy Rani, Scientist C, Deputy Director, BIS Hubli, for giving us a clear objective of the event. And Shri M. Pradeep Kumar, Scientist C and Deputy Director, BIS Hubli, for giving us an overview picture of BIS. And I would further thank our esteemed speakers, Dr. Somashekar Bhatt, Joint Director of MIT Manipal, and Shri Madhusudan R, Committee Member of BIS, as well as the DGM of JSW Steel Limited, who have graced this occasion with their wisdom and knowledge. They have shared their insights on sustainability and Indian standards that gave us a very informative knowledge. Thank you for your time and dedication. I would like to further thanks to our talented dance performers to show us the different colors of Karnataka through such a wonderful dance art. I would like to thank the organizing committee who has worked tirelessly behind the scenes to ensure that everything runs smoothly. Thank you for your hard work, dedication, and commitment. Last but not the least, I would like to thank the audience who have participated in this event. Your enthusiasm and active participation have made this event lively and interactive. In conclusion, I would like to express my sincere appreciation to each and every one of you for your valuable contribution towards the success of Manak Mahotsav. We hope to continue this journey together and make a positive impact in the world of industries. Thank you all once again. Thank you so much.
Ladies and gentlemen, as we draw the curtains off to this magnificent celebration of Manak Mahotsav on occasion of World Standards Day, we have explored how collaboration and innovation in standardization can lead us towards a brighter and more efficient future. Let's carry forward the spirit of unity and excellence that stands represent, working together to create a world where everyone can thrive. Before we conclude, let us express our heartfelt gratitude to our guests, performers, and participants who have graced us with their presence and contributed to the success of this event. A special thank you to all the organizing committee members, volunteers, and staff who worked tirelessly behind the scenes to make this celebration a success. Thank you all for being here. Thank you for your participation and commitment in advancing our shared goals. Together, let's continue to uphold and promote the standards that make a difference. On behalf of Bureau of Indian Standards, Hubli Branch Office, I, Emin Sheikh, wish you all continued success and we look forward to more milestones in the years to come. Have a wonderful evening. We have also made arrangements for tea. Please have tea in.